Welcome to The Explainer. Today, we're diving into something that is totally changing the game for artificial intelligence. I'm talking about OpenAI's CLIP, a model that's fundamentally rewriting how AI sees and understands our world. Okay, so here's the plan. We're going to start with why CLIP is such a huge leap forward. Then we'll get into the nuts and bolts of how it actually learns to connect words and pictures. We'll look at the super clever training method that makes it all possible, see the incredible things it can do, and finally, talk about where this is all heading. To really wrap our heads around why CLIP is so important, we first have to understand this huge shift that's happening in AI. We're moving beyond AI that just reads information to an AI that can actually perceive the world, kind of like we do. At the heart of this is a concept called a multimodal model. And it sounds way more complicated than it is. I mean, think about it. You don't just understand the word dog from a dictionary. You connect it to what a dog looks like, what it sounds like, the experience of petting one. Multimodal AI is trying to do the same thing, connect different types of data, in this case text and images, to build a much richer, more complete understanding. This slide does a great job of showing just how far AI has come. Early models were kind of like a student stuck in a library, only able to read one set of books, like all of Wikipedia. That was step one. Then, boom, step two. Models like GPT got a library card to the entire internet. They could read, well, everything. But CLIP is step three. It's not just reading the internet anymore. It's looking at all the pictures, too. It's connecting the words to the images, getting it so much closer to our own visual reality.
Okay, so that's the what. Now for the how. How in the world do you teach a machine to see a picture of a puppy playing in the grass and know that it matches the words, a puppy playing in the grass? Well, the solution is pretty brilliant.
So, CLIP cleverly uses two models working together. Think of them as two specialists. On one side, you have the text encoder, who's a total language nerd. On the other, the image encoder, who's the visual artist. Each one takes its own input, a sentence or a picture, and boils it down to its essence. It turns it into a list of numbers that we call a vector, which is basically a unique mathematical fingerprint for that concept.
And the whole point, the entire goal of the training, is to get these two separate experts to produce similar fingerprints for the same idea. You're essentially teaching them to speak the same abstract mathematical language. And this is where the magic happens. Imagine this giant, invisible map of every possible idea, what we call a vector space. The model learns to put similar things close together on this map, so the fingerprint for the text, two dogs, ends up right next to the fingerprint for the image of two dogs. And something totally different, like a skyscraper, is way off in another neighborhood. It learns to map out these relationships. Okay, so we know it's learning to map things out, but how does it learn to do that? Well, the secret is actually hiding in plain sight, right there in the name, CLIP. It stands for Contrastive Language Image Pre-training. Let's just focus on that CL part, contrastive learning. It's a really intuitive idea. The best way to teach a model what a correct match looks like is to show it that correct match alongside a whole bunch of incorrect ones. It learns by comparison, by, well, contrast.
Here's how it goes down during training. The model is fed a massive batch of data. In this batch are positive pairs, an image correctly matched with its caption. But, and this is the key, for every one of those correct pairs, the model also sees many negative pairs, which are just random, incorrect mismatches from that same batch. You can kind of picture it like this grid. You have a bunch of images on one side and their text captions on the other. The model's entire job is to learn how to produce the highest possible scores along the diagonal, where the image of a dog lines up with the text dog. And for everything else, all the mismatches, it wants those scores to be as low as possible. So the whole training is just this constant game of push and pull. For every correct, positive pair, it adjusts itself to pull their vectors closer together on that big map. For every incorrect, negative pair, it pushes their vectors further apart. And you do this millions and millions, even billions of times. And eventually, it builds this incredibly rich, nuanced understanding of the visual world and how we describe it.
Okay, so after all that training, all that pushing and pulling, what do we get? What can an AI that thinks this way actually do? This is where it gets really mind-blowing.
Let's take a really fascinating example. What do you think happens if you use CLIP to search a huge database of dog pictures for the phrase hot dog?
Now, a simple keyword search would just get confused here. But CLIP, it's different. Yeah, first it finds the literal answer, but then it gets creative. It finds pictures of dogs that are conceptually hot. A dog by a warm fire, a dog in a thick sweater. This is incredible because it shows the model isn't just matching text, it's grasping abstract ideas in context, almost like a human would.
And this ability leads us to what is probably CLIP's most powerful feature, its zero-shot capability. All this means is that it can perform a task it has never, ever seen before, without any extra fine-tuning or training. And this is the real game changer. You can invent new tasks for it on the fly. For instance, you can turn it into an image classifier without any training at all. Just give it an image and a list of text descriptions like a photo of a dog or a photo of a cat, and it'll tell you which one is the closest match. You can even use it for object detection. Describe what you're looking for, say, a fluffy cat, and CLIP can scan the image to find it. This flexibility is a complete paradigm shift.
And that brings us to the bigger picture. CLIP isn't just some clever model, it's a foundational piece of technology that is powering the current AI revolution that we're all living through.
I mean, if you've ever been amazed by the images created by models like DALL-E 2 or Midjourney, then you've seen CLIP's influence. It's the engine under the hood. CLIP is the part of the system that takes a text prompt, like an astronaut riding a horse in a photorealistic style, and translates that complex idea into a mathematical representation that the image generation model can then use to create the picture.
This technology is what allows AI to finally bridge that gap between our language and visual concepts. It's already unlocked a new era of creativity and capability, and really, we are only just scratching the surface. It leaves you wondering, now that AI can understand us in this multimodal way, what becomes possible next?